Hello there, guys. We are back again for studying and for solving, for explaining the other part of the sections was left. The first part we studied the concave spherical mirror, but now we have the second type of the spherical mirror, which is called convex spherical mirror. Before to explain, let me show you how is this shape of convex spherical mirror. This is the shape of convex spherical mirror. This is the shape of convex spherical mirror. It's like that. Look, we explained it the previous video. If we have this curve to the left direction, this is called concave, but to the right, this is called convex. So this one is the convex spherical mirror. Okay, now we are going to be explaining part. First of all, now in here that you have the definition of convex spherical mirror. Convex spherical mirror, a mirror, of course, mirror, whose reflecting surface is outward curved segment of a sphere. So as we know that, like the other one, like the other video that I have told you, we have this sphere. We have this sphere. So we have this sphere. We explained it before. If we are taking this part, if we take this part of this sphere, take this part of the sphere, take this part. If we'll take this part, will be concave spherical mirror, right? And because this is inside the sphere. But if you take this part of the sphere, the directions, the surface is like that. If we take this part, we see that the surface direction is to the right. So this is called convex spherical mirror. So this is called convex spherical mirror. And the convex spherical mirror definition said a mirror whose reflecting surface, again we are using this mirror Y for reflecting surface, reflecting light, is outward curved segment of the sphere. Outward, because if we are taking this part, we see that the direction of this part is to the right side, and outward. But this one is inward. Now we have one of the questions in here. What is the use of convex? Why we are using convex mirror, or what is the application of convex mirror? Use it in rear view mirror in cars, as they enable driver to view the road and cars behind. If you see that in front of the cars, from right and left, there are two rear view mirror. There are two rear view mirror. Why we are using the rear view mirror in cars? To see the car that it will come behind us, to see the roads, or to see how many cars are coming behind us. So this type of the mirror that we are using in car, this is convex spherical mirror. Convex spherical mirror. I think convex spherical mirror. We have some notes important. You should know actually. In convex spherical mirror, the image is virtual and upright every time, and the magnification is less than 1. Yeah, the image that we get, the size of the image less than the size of the object, and located behind the mirror. Why located behind the mirror? We know that because this is virtual. We have explained, if it's virtual, the image going to be produced behind the mirror. Good. So now we are going to be solving an example. To solve example, so let me tell the idea about this picture. Look, take a look in here. If to put this object in here, we see that, as I told you, every object, they are emitting a lot of light. So in here we are taking only three lights, three line. The first light came out from this source. It's going to be reflected this convex, and it's going to be reflected back in that direction. And this is the second light, go reflect that in that direction, and this is the third light. Okay, we see that when the light are hitting this surface, and it's going to be reflected in a random direction. One of them goes in that direction, the other left, and the other in that direction. So the image going to be produced, look behind the mirror, behind the mirror. That's why it's called what? Virtual image. This is virtual image because the image going to be produced behind the mirror. If you see that in here, the magnification less than 1. Why less than 1? Because the size of this image less than the size of this object. Good. So let me solve example now. Good. But students, to only tell you one thing. In convex spherical mirror, every time in convex spherical mirror, the focal length and r, radius of the curvature, every time it's minus. In what? In convex spherical mirror. With q, image distance, q, focal length, radius, curvature, all of them are minus. But p, object distance, and h, image, the image distance with magnification, these all of them are positive. Okay, so now let me solve the example. Let's memorize actually this image distance q, f, r negative, and p, h dash, m positive. Example, an upright pencil is placed in front of the convex spherical mirror. Yani, look, we are putting this pencil in front of this convex spherical mirror. Okay, with a focal length which is equal to 8. We said in convex spherical mirror the focal length must be negative. So in here you have to add what? Negative 8. An erect image 2.50 centimeter tall is formed. Image, so this is q, image, it will be negative, as I told you, q, negative, and 44 centimeter behind the mirror. So this one, that one's, guys, in here, because it is written tall, this is tall, and this is the height h dash, it must be positive, but this is behind the mirror, this is the image behind the mirror, because virtual, so q's must be negative. Find the position of the object, find p, and magnification, find m, and the height of the pencil, find h. Good. Yalla. Let's solve this example now. The value of f negative 8 centimeter, and the value of q equal to negative 4.44 centimeter, and the value of h dash 2.50 centimeter. We are going to find p, object distance, and h with magnification. We are going to apply the same rule, 1 over p plus 1 over q equal to 1 over f. First of all, go to find the value of p. 1 over p plus, where is the value of q? We have in here negative 4.44. 1 over negative 4.44 equal to the value of f negative 8, 1 over negative 8. How we can get the value of this? How we can get the value of p? First of all, you have to take this fraction to the right side. Equal 1 over negative 8, take it to right side, will be positive 1 over 4.44. 1 over p. So minus both of them, since different sign we have 1 over 8 negative 1 over 8 plus 1 over 4.44. So the answer 0.100, 1 over p. As I told you, to get the value of p, flip this number, p equal to 1 over 0.100. The answer will be 10 centimeter, the object distance. Okay, the object distance 10 centimeter. Then we found p, h is left with magnification. h m equal to h dash over h. We have this rule. If you remember, we can apply this rule, m equal to h dash over h. First of all, in here we can, or even we have this rule too, m equal to negative q over p. We have q and we have p. We can find magnification now. So first of all, we are going to be applying this rule. M equal to negative, this negative of the rule, and the q still is another negative. We have negative 4.44, so it will be 2 negative and negative 4.44 over the value of p. The value of p we found in here is 10. So negative and negative will be positive, so 4.44 divided by 10. 4.44 divided by 10. The answer is 0. Magnification equal 0.444. We found magnification, only the height of the object is left. M equal to h dash over h. We found m, the magnification. Instead of magnification, write down 0.444 equal to h dash, the image height of the image 2.50, and we are going to be find h. Switch the place to find the height of the object. H equal to 0.444 and 2.50. 2.50 divided by this number, 2.50 divided by 0.444, the answer 5.63. So the height of the object 5.63 centimeter. 5.63 centimeter. Practice 5C, question 1. The image of appears to be 23 centimeter behind the surface of the convex mirror. Behind, it means again this virtual image, because in here we have behind, and the value of this q will be negative. And 1.17 centimeter behind convex spherical mirror, right? 1.70 centimeter. So this h dash, because this in here it is written tall. So q negative 23 and h dash, as we said, h dash, it must be positive, right, in convex spherical mirror. Let's take a look. Positive. So H dash positive. If the mirror focal length 46 centimeters, so this 46 focal length must be negative. Okay. How far in front of the mirror's position? So in here the question said, find the how far. It says in here we have Q, so it means find the object at distance P. Then what is the magnification? Find magnification. Is the image real or virtual? Is the image inverted or upright? How tall the object? Even though we have to find H. Okay. Take a look at here. Let me write down all the parameters that we have in here. First of all, in here, look. Question 1. Q, the value of Q, which is equal to negative 23 centimeter. We have to add negative because the question said behind the surface, and behind the mirror, this is virtual. And 1.70 centimeter tall. The image H dash 1.70 centimeter tall. If the mirror's focal length negative 46 centimeter, because in convex spherical mirror the focal length is negative. Find the object at distance, and what is the magnification, and find the P, and what's the magnification, and what is the height of the object. Good. First, we are going to be applying the same rule, 1 over P plus 1 over Q equal to 1 over F. 1 over P, the value of P, we want to find the value of P, plus the Q is negative, 1 over negative 23 equal to 1 over negative 46. So take this number to the right side. 1 over P equal to 1 over negative 46. Take it to right loop plus 1 over 23. Good. 1 over negative 46 plus 1 over 23. We are going to be minus. Use calculator. The answer 0.0217. This is the answer of 1 over Q. But to get the value of the object at distance P, as I told you, you have to flip this number, flip the value, flipping. P equal to 1 over this result, 0.0217. 1 divided by 0.0217, the answer 46. So P, object at distance 46 centimeter. We found the value of P. Then find magnification. M equal to negative Q over P. We have the value of Q, which is equal to negative 23. This negative of the root, write down the negative, and the value of Q, again you have another negative, negative 23. So we have to write down this inside the bracket, negative 23. And the value of P here, we found the value of P, which is equal to 46. Negative with negative will be positive. So 23 divided by 46. 46, the answer will be 0.5. 0.5. Then the height of the object is left. This height of the object, again, we are going to be applying this rule easy. H dash over H. We found magnification, which is equal to 0.5 and equal H dash image size of the image, or the height of the image. We have 1.70. We will be applying. We will be finding now H. Switch the place again. Switch the place of both of them. H equal to 1.17 divided by 0.5. 1.17 divided by 0.5, the answer 3.4. 3.4. So this is the value of the object size, and this is the value of the magnification, and this is the value of the P. So Q, where is the value of P? Sorry, the value of the P 46, and the value of the m 0.5 and the value of h 3.4. This is question 1. Question 2. Question 2. Question 2. Question 2 said a convex with focal length 0.25 meter in here. Question 2. Because in here that you have by meter 0.25 meter, because again convex, so the value of f it must be negative. The value of f negative. Focal length negative 0.25 meter. Forms as 0.08 t a tall image. Tall image, and the size of the image, height h. It's positive, of course, still it's h dash 0.08 t. A very mobile and a distance 0.24 behind the mirror. 0.24 behind the mirror, actually. Behind the mirror, now this is the image distance that in here we have behind the mirror. So because behind the mirror and virtual, so this value will be negative. Q equal to negative 0.24 meter. What is the magnification of the image? Find magnification. Where is the car located? Yeah, find object at distance. And what is the height? The height of the object. Is the image real or virtual? Okay. I'm sorry guys, actually I forgot in the previous question here to tell you, is it virtual or I forget actually, sorry. Is the image real or virtual? Question 1. Let me check the answer. Question 1, because in here we have convex spherical mirror and the image in here, and the image going to be produced behind the mirror, because you have behind the mirror and the type of the image virtual. Because it's virtual, it means the image is upright, virtual and upright, because you have behind the mirror. So this is virtual, and is the image inverted or upright? Upright, virtual and upright. Virtual, upright. Question 1 answer. Virtual upright. I forgot to answer this part actually. Virtual and upright. Because this convex spherical mirror. Good. So another question 2. Okay. Question. We said question 1, it was virtual and upright. Okay. Yeah. Question 2. Yeah. Now the question said, what's the height and is the image real or virtual and is the image upright? Okay. Then look. This is the question 2 answer. Question 2 answer. You have all of them, and we are going to be finding now P, object at distance. Same rule, 1 over P plus 1 over Q equal to 1 over F. the value of P, we want to find the value of P plus Q value. We have negative 0.24. 1 over negative 0.24 equal to the focal length negative 0.25, negative 0.25. So then take this fraction to the right side. 1 over P equal to 1 over negative 0.25. Take it to right side will be positive 0.24. Subtract both of them. Let me check calculator. If to subtract both of them, the answer will be 0.166, 1 over P. To get the value of P, flip this fraction, this number, divided 1 over this result. 1 over 0.66. So the answer will be 6. So the object distance 6 centimeter. The object distance will be 6 centimeter. What about the magnification? Magnification equal to negative Q over P. The value of Q, image distance, you have negative 0.24. You have another negative, and with negative other will be positive. Negative 0.24, and the value of P 6. Negative with negative will be positive. Positive 0.24 divided by 6. The answer will be, you can divide it, will be 0.04. Only now the height of the object is left. To find the height of the object, m equal to h dash over h. Switch the place to find the height of the object. H equal to h dash over m. H dash 0.080 over the magnification we found in here. It was 0.04. Divide both of them, so the height of the object will be 2 meters. Good. So the question said, is it virtual or real? Is it upright or... Look, in here, since the question said, in here we have convex spherical mirror, and the question said we have image behind the mirror. Again, look. We have behind the mirror. Behind the mirror, it means virtual, directly. Behind the mirror, يعني the type of the image virtual. Okay. Virtual. Okay, virtual. Virtual. And virtual again will be upright. Every time virtual, يعني will be upright. Virtual upright. Question 3. Question 3. Question 3. A convex of focal length 33. Because we have focal convex spherical mirror, and the focal length must be negative. And here we have to add negative by ourselves. Forms an image of soda bottle at a distance 90 centimeter behind the mirror. So this will be negative because this is the image distance behind the mirror. The value of Q must be negative. So focal length and Q will be negative. If the height of the image 7, this is still positive, يعني H dash. Where is the object located? Find object located P. So this is the value of F, focal length, and that's that one Q. So in here you have to find the value of P. And how tall is it? How tall is it? So find the H object height. And what is the magnification? Find M. Is the mature or unknown? Okay, and so on. Same thing. Easy actually. Yeah, question 3. A convex spherical focal length 33 negative because it's convex. If it's convex, Baba, every time the focal length will be negative. Focal length will be negative 33 centimeter. Forms an image of soda bottle at a distance behind the mirror. Behind the mirror, and this value negative. And Q will be negative 19 centimeter. Q negative 90 centimeter. If the height of the image, if the height of the image h dash 7 centimeter, where is the object located? يعني find P. And how tall is it? How tall is it? Find H. What is the magnification of the image? Find M. Is it real or virtual? And later we will discuss this. Okay, yalla. We will be applying the same rule again. One over P will be 1 over P plus 1 over Q equal to 1 over F. The value of P, we have to find the value of P. Write down again, copy this part, 1 over P plus, and here we are going to be finding the value of Q. Sorry, no. We have to find the value of P, but in here we have the value of Q, which is equal to negative 90, 1 over negative 90, equal to the focal length negative 33, 1 over negative 33. To make this 1 over P alone, take this fraction to the right side. So 1 over P equal, write down this, 1 over negative 33, and take it to the right side will be positive 90. So different side become minus both. Negative 33 plus 90. The answer will be 0.022. To find the value of P, flip this. Flip it, will be 1 over 0.022. So the answer 45. The answer of P 45.4. 45.4 centimeter. To find the magnification equal to negative Q over P. The value of, we have to copy again the sign of the rule, negative, and the Q again, there is another sign of the Q value, negative 19. Just take care, guys. In here, this is the negative of the rule, and here this is the negative of the value of the Q. So negative with negative will be positive. The value of P we found in here, which is equal to 45.4. So it will be positive actually. 90 divided by 40, 90 divided by 45 will be 0.0418. This is the magnification. This is the magnification, and this is the value of P. Only the height is left. Height M equal to H dash over H. To find the value of this height, again switch it with M magnification. H will be H dash over magnification, and H dash in here we have 7, and the magnification value we found, which is equal to 0.418. So divide both of them. The answer will be 17. Magnification will be 17 centimeter. And the last part of the question said, is the image virtual or real? In here, of course, the image, because in here we have negative sign, the Q is negative, and the question said behind the mirror, so of course this is virtual. And because virtual, again, this is upright. Upright. Okay. Question 4. Question 4. a convex mirror with a radius curvature. In here we have R, radius, and I have told you in here if the R in convex spherical mirror still it will be negative. Be careful. In here I give you this note if you remember. Take a look in here. As I told you in here, the value of Q and FR will be negative in convex spherical mirror. So since in here it is written convex mirror, so the value of radius of curvature must be negative. It is placed above in a store determine the image distance and find Q and magnification M. Lying on the floor 31. A magnification on the floor 31 meter below the mirror is this number so this value P line a terminal lying on the floor is 3.1 below the mirror. Is the image real or virtual? Actually, this is the same thing. We're going to be finding now this. Okay. It was question 4. Yes, question 4. A convex mirror with a radius of curvature, and this is the radius of the curvature, and we said it must be negative 0.550. Is placed above the store and determine the image distance. Find Q and magnification, and we have the value of P 3.1. Okay, 3.1 is the image real or virtual, and so on. Good. Find the value of Q. Yeah, 1 over P plus 1 over Q. Students, in here, because we don't have focal length, and instead of focal length, we have radius of the curvature. So we are going to be write down the other rule, 2 over R. Okay, 2 over R. Yeah, the value of P we have 3.1 plus just let me fix this, guys. Sorry. Plus we have to find the value of Q1 over Q equal to 2 over the radius negative 0.550. To make this 1 over Q alone, write down this 1 over Q, and take this number to the right side. 2 over negative 0.550, take it to the right side, it will be negative 3.1. Uh, 2 over negative 0. Minus 1 over 3.1. The answer will be 4. 1 over Q, negative 4. To get the value of Q, we have to flip this number. 1 over 4 will be negative 0.25, I think. Yes, 0.25. The value of Q is 0.25. Then we are going to be finding now, we found the value of Q. Magnification. Find the value of magnification equal to negative Q over P. Write down the negative of the rule, and Q value we found in here. Again, there is another negative 0.25, and the value of P 3.1. So negative with negative will be positive. So 0.25 divided by 3.1, 0.25 divided by 3.1, the answer 0.080. 0.080. The question said, is the image real or virtual or upright? Because in here, the value of Q in here, look, take a look, it's negative. So it means this is virtual. Virtual and upright. Virtual and upright. Question 5. Question 5. Question 5. The question said a spherical glass has 6 centimeter diameter. In here, instead of radius, you have diameter. So diameter symbol D capital. If an object is placed 10.5 centimeter away from this object ornament, if an object is placed, so this is the value of P. Where will its image form? Find the value of Q. What is the magnification? Good. Yalla, to solve question 5. Question 5. Spherical glass, the diameter D equal to 6 centimeter. If an object placed, so the value of P equal to 10.5 centimeter away, where will its image form? Find the value of Q. Find the value of Q and magnification. Students, take a look in here. You have to write the other rule again. 1 over P plus 1 over Q over 2 over R. But in here, we have a problem. R, it means radius. But in here, instead of radius, we have diameter. So in math, you studied how we can make this diameter to radius by dividing by 2. 6 divided by 2 will be 3. So this 3 now, this 3 is radius. Because radius is half of diameter. Diameter twice than radius. If the diameter is 6, radius will be 3 divided by 2. To convert diameter to radius, divide this number by 2. So the value of radius is 3, right? So the value, which is equal to 3. By dividing by 2, we can convert to radius. But in here, because the type of the spherical is convex, again, we have to add negative. Okay, we should add negative to solve. Yeah, let me solve the next question. With the value of P we have, again, 10 over 10.5 plus 1 over the value of Q. We want to find the value of Q equal to 2 over the value of R, negative 3. Bring down 1 over Q. Take this fraction to the right side. 2 over negative 3, take it to right, will be negative 1 over 10.5. 2 over negative 3, negative 1 over 10.5, negative 0.080. 76 1 over q. To find the value of q, flip this number again. 1 over 0.76. So the answer 1.33. Negative 1.33, 1.31, sorry, centimeter. So because the value of any negative, it means this again virtual and upright. Virtual and upright. Question 5. Question 6, last questions left. Students, question 6, actually it's like the other question. Yeah, now in here I have solved all of the questions for you. Only question 6 left because it takes time actually. It will be homework. It will be homework for you. Solve it by yourself. It's easy like the other question. If you have problem, you can text me later, okay? We are reaching in this last part of this topic, which is called parabolic mirror. Parabolic mirror. Students, in here, what is parabolic mirror? Parabolic mirror, it means the definition. Where is parabolic definition? In parabolic mirror, so guys, parabolic mirror in here that you have this part is left. Parabolic mirror, but first of all, let me explain. In here we have one of the topic which is called spherical aberration. Spherical aberration. In here we have a spherical aberration in here. Look, what is spherical aberration? Students, only look at this picture. We have this spherical mirror. When we have a lot of parallel line, they are a series or a lot of parallel line, they are coming together, and after we know that all of the light are reflecting back in that direction. All of them are reflecting back in randomly direction. So in here we see that after reflecting, we see that when the light are came in that direction, after reflecting, we see that the light, when they are reflecting, they are not passing at the same point. I mean, in here, the light they have to pass at the same point, which is focal point in here. But they are not passing. All of them, they are not passing to the focal point. If you notice that this light, if you notice that this light came in that direction, then it's going to reflect back in this direction. The other ones came reflect back in that direction. So I means all of them, when they are reflecting back, they are not passing, they are not going through the focal point, all of them at the same time. So this is problem. This is problem actually. So this problem is called spherical aberration. Spherical aberration in here, take a look, occurs when a parallel ray, we have a parallel ray from the principal axis converge away from mirror of the focal point. It means all of the light after reflecting back to the surface, they are converging away. They are passing through away to the focal points. In general, when all of the light they are coming, they are not passing to the focal point. All of them, they are reflecting by a random direction. So in that case, we will get a problem. This is called spherical aberration. Spherical aberration, actually, this is problem. We know why, because the image, when the image can produce in this spherical aberration, the image become not clear, not vivid. I can say like that. For example, the image become blurry. So the image not nice, and you cannot see the detailed image. The image won't be clear. So spherical aberration, actually, this is problem. So how we can fix this problem? How we can fix this problem? But before that, how we can fix this problem? Instead of using spherical aberration, we will use a parabolic mirror. We have in here parabolic mirror. Why we are using parabolic mirror? To achieve an image without spherical aberration. Yeah, to get image, to get a nice image, to get a detailed image, to get a clear image without spherical aberration, without getting blurry, without getting a bad picture, bad image. So to fix this problem, and instead of using spherical aberration, we are going to be using parabolic mirror. The second useful, the second thing that you have to use parabolic mirror, using flashlight and automobile light and headlight on the reflecting telescope. This is one of the application. We are using parabolic mirror in a flashlight, automobile light, and headlight reflecting telescope. This is the parabolic mirror. Look at the difference between them. This is a spherical mirror and this parabolic mirror. We are make this curve like that. We are going to make it a lot of curve. Why we are doing this? Because when all of the light are came in that direction, all of the light, there is a lot of parallel light. All of them, if you notice that, take a look. All of them, after reflecting back, we see that all of them, they are passing through the focal point. All of them, they are passing through focal point, all of them. So in that case, we will get a nice image, a clear image without getting any problem. So to fix spherical aberration, you have to use a parabolic mirror. Take a look, a parallel rays converge at a parabolic mirror focal point. And the parallel ray, all of them, they are focusing to the focal point. The curvature in this figure much greater than the real parabolic mirror. Okay, so all of them, they are converging to the focal points and to get a nice image. Another question here we have, what is the way to reduce or to eliminate I think I forget in here. No, in here. Okay. What is the way to reduce or eliminate the effect of spherical aberration? As I told you, by using parabolic mirror. What is the way to reduce, to get a bad image, bad picture, blurry or not clear image? By using the only the way that you can fix this problem, by using parabolic mirror. One thing that's left in here, we have a telescope definition. Actually, I think all of you know what's telescope. Telescope permit you, it assists you, it can allow you to what? Permit you to view a distant object, whether they are a building a few kilometers or a galaxy that are millions or light years from the Earth. For example, in another universe, there's a lot of galaxies, there's a lot of objects there, but the distance, the universe with the Earth, it's so far. So how we can see those kind of this object in the another universe? There's a lot of distance actually by using telescope. Telescope, it's a useful things like all the scientists that they are using this, for example, to using a different kind of galaxy that we have in this universe. We have two types of telescope. There are two types of telescope that use visible light. One of the type called a refracting telescope. This refracting telescope, important to know that for multiple choice, uses a combination of the lens to form image. But the other kind of curved mirror, which is called the other kind, uses as a curved mirror and small lenses to form image. So the first type, as I told you, refracting telescope, that is combination of lens to form image. The other one we have reflecting telescope. The reflecting telescope, this kind uses as a curved mirror and small lenses to form image. Uses curved mirror and small lens. Curved mirror and small lens. So you have two types, refracting telescope and reflecting telescope. Finish, we reach this section reviewing. Let me solve this example, question 1. Actually, we have solved this, all of them, but still I'm going to be solving for it, okay? Question 1. Question 1, the question said, a steel ball bearing with the radius r 1.5 centimeter forms an image of an object that has been placed at 1.1 centimeter away from the bearing surface. So this 1.1, it's P, because in here it said a radius 1.5 centimeter forms an image of an object that has been placed. And you are putting an object, so this is the value of P, object distance. Determine the image distance and magnification. Determine the image distance and magnification. Yani find Q and M. Is the image real or virtual, and so on. Okay. So first in here that you have radius 1.5. Sorry, the radius R like that. Okay. So we said the R must be negative in convex spherical mirror, and we have Q, the value of Q 1.1, still it will be negative. Sorry, the question said find Q. No, you have to find the value of Q. And the value of P equal to 1.1. Determine the image distance, yani find Q and magnification. Now the same rule, apply the same rule, 1 over P plus 1 over Q equal to 1 over F. And instead of P that you have 1.1 plus 1 over Q equal to the value of P. As I told you, we don't have F, so instead of that you have to write down the rule. It was 2 over R. 2 over R. 2 over R. To find this fraction, write down again. Take this number to the right side. 2 over R will be negative 1.1. Instead of R, write negative 1.5. Negative 1.5 minus 1.11. At the same time, you have to add the number. You can use calculator and to get the result of this number. Negative 2.24. Negative 2.24 1 over Q. To get the value of Q, flip this number, will be 1 over negative 2.24 2.24, and the answer 0.446 negative 0.446. Okay. The answer negative. So the property, of course, are virtual and upright. And the magnification is left. To find the magnification, negative Q over P. The value of Q that you have found in here, and this is the negative of the rule, and the value of Q, just we have another negative 0.446 over the value of P 1.1. Negative with negative will be positive. So 0.446 divided by 1.1. 0.446 divided by 1.1. The answer is 0.40. The magnification equal to 0.40. Question 2. Question 2. Spherical mirror is to be used in a motion picture projector to form an inverted real image. 95 times as the tall picture single frame film, the image projected on the screen 30 meter. What type of mirror required? How should be? Students in here, the question said a spherical mirror is to be used in motion picture projector to form an image inverted real image inverted. In here this is important. The question said inverted. Inverted, we said if the question said inverted, it means what? Inverted real, inverted image real. So the magnification, inverted real magnifications will be negative. Magnification, the magnification will be negative because the question said inverted and real. 95 times. And the magnification here that you have negative 95. As tall as the picture on a single frame film, the image is projected on the screen 30 meter from the mirror. So this is the image Q. Q 13 meter. Do not touch the value of Q, it's positive. Then what type of mirror is required? How far should be from the... Okay, I find the value again of P. I'm going to solve it in here, okay? Find the value of P. Because here the question says inverted and real. Inverted and real, because it's a real image, so the magnification must be negative, add negative. So only we have to find the value of P, objective distance, so directly use this rule. M equal to negative Q over P. Equal to, write down the negative, and the value of Q 13, the value of P negative 95. So negative with negative will be positive. So 13 divided by 95 will be 0.14 meter. 0.14 meter. We have the value of Q, negative 25 with negative will be the value of Q 13, right in the value of 13, and the value of M negative 95, negative with negative will be positive. Good. So question 3. Question 3. Question 3. And the value, but students, I forgot in here. The question said, and what kind of mirror that? What type of mirror in here is required? Actually, in here we require concave. Concave. You know why concave? Concave, because in here it's written inverted and real. In concave spherical mirror, the type of the image every time inverted and real. But in convex, if you remember, in convex it was different. In convex. In concave spherical mirror, it was real because the image you have in front of the mirror and inverted. Good. Question 3. Question 3. I'm going to be tell you in here. So let me erase this. Which following image are real and which are virtual? Part A. The image of a distance illuminated building project onto a piece of the heavy white cardboard by a small reflecting telescope. Because we have reflecting telescope, so A, real. Part B, rear view mirror. In a flat rear view mirror, so we have explained it. In a flat rear view mirror is virtual. You know why virtual? Because we said in a rear view mirror, so which type of mirror that we have? Convex spherical mirror, right? So in convex spherical mirror, we will get which type of image, real or virtual? Convex spherical mirror. In convex spherical mirror, every time we get virtual image. And in here, look, convex spherical using rear view mirror. So we are using rear view mirror. So this rear view mirror is virtual. Look, I wrote in here for the question. So you know this. That's why this is virtual. This is the reason. Part B, virtual. Image of the shop convex observation mirror. The question already they said convex, because said convex and it's again virtual. Part B, because we have rear view mirror virtual. Part C, because we have convex, again virtual. Students, we finished this section actually. Thank you for watching and have a nice day.